Number 11 says a lighthouse built at sea level is 150 feet high. So we've got a lighthouse. I don't really know what a lighthouse really looks like. Something like this, I guess. 150 feet high. From its top, the angle of depression of a bayou is 25 degrees. So I guess there's like some water here. And we've got a little thing in the water. So it says find the distance from the bayou to the foot of the lighthouse. So we're looking for this distance here. That's going to be our right angle. I know I drew it kind of slanty. Sorry about that. Now, it says the angle of depression. If I'm looking down here, this is not the angle of depression. The angle of depression needs to be from looking straight out and pressing down. So this is actually the angle of depression. When you look straight and you press down, that's your angle of depression. Keep in mind that looking straight out and sea level are parallel. So when we have parallel lines cut by a transversal, we have alternate interior angles which are congruent. So if we know that this angle of depression is 25 degrees, that means this angle is also 25 degrees. From there, I can redraw my triangle. I've got 25 degrees, X, and 150. Then from there, I need to use trig in order to solve for that missing side length. So first, I'm going to label my hypotenuse, which is across from my right angle. This is my hypotenuse. My hypotenuse was not used. It did not have a variable. It did not have a number attached to it. So I'm just going to put an X so that I remember I'm not actually using my hypotenuse. I just labeled it so I could find it and not get it confused with anything else. Now, 25 degrees, if I go across from that, then I will have my opposite side. And right next to it is my adjacent side. Now, when we have SOHCAHTOA, and I am dealing with opposite and adjacent take place with our trig function tangent. So, tangent of 25 equals opposite over adjacent. Then from there, I need to put tangent over 1 in order to cross multiply. 150 times 1 is 150, and X times tangent of 25. I need to get my variable alone, so what I need to do is divide both sides by tangent of 25, because that is the inverse function of multiplication. So in order to kind of get rid of that multiplication, I need to divide. So I'll divide whatever you do to one side, you must do to the other side of the equal sign. One on that side, one on this side. These cancel each other out, and we get X equals 150 over tangent of 25. So I'd plug that in. 150 divided by tangent of 25 gives me 321.68, because that 7 will look to his neighbor, which is greater than 5, which bumps it up to an 8. So I get X equals 321.68. Did they give us a... Yep, they gave us our units of feet. And again, that is this distance from the... Oh, that's a... Okay. That's a buoy, not a bayou. Sorry. But from the buoy to the lighthouse. Now, if we look at number 12... A train in the mountains rises 10 feet for every 250 feet it moves along the track. So, this seems like a slope problem, but think about it. It's going to rise 10 feet for every 250 feet it moves along the track. So, I kind of drew this upside down. Let me redraw this, I'm sorry. There we go. All right, so it's going to rise 10 feet for every 250 feet it moves along the track. So if you think about it, it's going to move 250 feet and then rise 10. If I had drawn it that way, it would work too, but in order for us to know where the angle of elevation is, we should move along and then go up. So this is 250 feet, this is 10 feet. Now, our angle of elevation starts at ground level and moves up, like an elevator goes up. So really we're looking for this angle right here, which is theta. In terms of theta, this will always be my hypotenuse across from the right angle. Here's my hypotenuse. My hypotenuse is not used, so I'm going to put an X on it. There's no variable, there's no number written. Then 250 is right beside theta, so that makes this adjacent. Across from the angle is my opposite side. So looking at SOHCAHTOA, I will be dealing with my opposite and adjacent sides. Opposite and adjacent are my tangent functions. So tangent of theta equals opposite over adjacent. Now, there are no variables on this side. So what I need to do, and since this is all one piece, I can't divide by just tangent or just theta. It's all one piece. What I need to do is I need to switch my input and output and take the inverse. So inverse tangent of 10 over 250 is going to give me theta. So I took the inverse and switched my input and output. Then from there, I need to find my inverse tangent, which is this blue guy right here. So I need to press my blue button and tangent, and then it pops up inverse tan. 10 divided by 250 gives me 2.29. So theta equals 2.29 degrees. And then if you think about it, if I'm going to go 250 feet and only go up 10 feet, that angle needs to be very small. So yes, that is true. Now looking at number 13. A plane rose from takeoff and flew at an angle of 11 degrees with the ground. So here's the ground. This looks more like a shark. Okay, there's my plane. And the angle in which it left was 11 degrees. When it reached an altitude of 500 feet, so altitude will always be perpendicular. The height is 500 feet. What was the horizontal distance? Like how far had it gone? This is horizontal. Think about the horizon being flat across. So I can always redraw my triangle to make it easier to see. I've got 500, 11, and x. So across from my right angle is my hypotenuse. Nothing is written there, no variable, no number. So I'm going to pretend like that's not even there. But my hypotenuse is marked. Then if I'm given the angle that measures 11 degrees, the side right beside it is my adjacent side, and the side across from it is opposite. So if I'm dealing with adjacent and opposite, we will still be using tangent. So I know that tangent of 11 degrees equals opposite over adjacent. From there, I need to put tangent over 1 and cross multiply. 500 times 1 is 500. And x times tangent of 11. I'm sorry. Let me pull this over so we can see what I'm doing. So in order to get rid of my tangent, to get my x by itself, I need to do the inverse operation of multiplication, which is division, and do tangent of 11 divide by tangent of 11. Those cancel each other out, and I get x equals 500 divided by tangent of 11 degrees. So I can do 500 divided by tangent of 11, which gives me 2,572.28. So x equals 2,572.28, and it gave us the units being feet. And if you think about it, 11 degrees is very small, so this needs to be a pretty far distance, because the smaller the angle, to get taller, we need to have a longer distance. All right, number 14. We've made it to the end. A tower is 125 feet tall and uses 200 feet long support wires attached to the ground. So that means if we've got a tower, it's got a wire that comes down and holds it to the ground. The wire is 200 feet long. What is the angle of elevation that would be necessary to use these wires, these support wires? So what is this angle right here going to be? The hypotenuse of my triangle will always be across from my right angle. Then if we're talking about the angle of elevation, that'll be from the ground up to the building. So this is the angle we're talking about, and across from that will be my opposite side. I'm going to be using my sine function because sine deals with opposite and hypotenuse. So sine of theta equals opposite over hypotenuse. Now I don't have a variable in my ratio, so what I'm going to need to do is take the inverse function where I switch my input and my output and say inverse sine of 125 over 200 equals theta. Then all I need to do is plug that in to my calculator and say inverse sine of 125 divided by 200 gives me 38.68 degrees because we're talking about that angle measure. Good luck on your test.